Yeah, the recording has started, so let me again now. What has happened? Yeah. स्क्रीन शेअर नाही केलं का मी अजून?
नाही सर.
नाही सर.
आता झाला असेल.
हो सर झालं.
Yes. So we spoke about how we tend to classify air masses on the basis of geographical locations. Okay, and with regards to these geographical locations, we have said we can classify them as tropical, we can classify them as polar. Now, as we have earlier seen also that for further details, some references are made wherein within tropical you may classify the air masses as equatorial also, and as far as near polar are concerned, you may classify them as Arctic or the Antarctic air masses as such. We are not going to go into all those details. The only thing is, with regards to this further in geography, is that with reference to location, further we'll see whether the air mass develops its characteristics from land. If it is from land, we are going to call them as continental. If they develop from, and that's going to be denoted with a small c, and if it is from the source of water, then we are going to denote it with a small m, that's maritime. The same thing happens with polar air masses also, polar continental, or you could say maritime polar also. Then we have been speaking about the the temperature of the air mass, in the sense now this is a surface and the air here is going to be of a particular temperature. It may so happen that due to wind, an air mass may come into this particular area. Now, the temperature of this particular air mass, you have to check the temperature. If this is higher than the local temperature, this is the local temperature. If the temperature is higher, then this air mass is going to be called as warm and it is going to be denoted with a W. But if the temperature is going to be lower instead of being higher, okay, than the local temperature, then it is going to be a cold air mass, however represented by a K and not by a C. You have to keep this definitely in your minds as such. And then you'll see the next is what is called as a dynamic relationship, in the sense that whether this coming air mass is going to be stable or unstable. As far as stability and instability is concerned, we have seen as to how if it is unstable, it will try to go up, and if it is stable, it is going to stay there as such. Now, all this was studied around the Second World War by Norwegian scientists. Okay, this was a father and son association, and the names I said yesterday were Jerkins. Okay, and that's why this Jerkin theory, it's called as the Jerkin theory of frontogenesis. Now, what is frontogenesis? We'll slowly go to that as well. Okay, we have seen all these classifications, the characteristics of each of them. Okay, and then let us move to what is called as frontogenesis. Now, for this, we'll have to understand a small thing. Okay, you'll see that frontogenesis is normally seen near 60 degrees of latitude. What do you have near 60 degrees of latitude? What pressure belt will you have near 60 degrees of latitude? Anybody remembers what is the pressure belt there? You're going to have high pressure or low pressure?
High pressure.
High
60
pressure.
degrees latitude.
Low
60 degrees
low
लॅटिट्यूड
pressure.
हाय
Low pressure.
Low pressure. Low
हाय
pressure.
नाही म्हटल्यावर लोच असलं पाहिजे. बरोबर आहे, बरोबर आहे, छान. It is low pressure. High pressure इकडे आहे रे, and then you have another low pressure near the equator. What we are interested here is this particular location around 60 degrees. Here is where, say, the frontal theory, as it is called, was explained. Okay, there are going to be a few things that we are going to be needing, and one of them is this particular key. You're going to require what is a cold front, what is a warm front, okay, a stationary front, and an occluded front. You'll see that there are symbols which express these fronts, and you can see the symbol here, and you can see the symbol here also as such. Now, what exactly is happening here? Now, you have to remember that from these high pressure wells, mid latitude high pressure wells, you had these westerlies which are going this way, right? And as far as the polar easterlies are concerned, you're going to have the winds coming in the form of this cold winds. Okay, I've already said that this coldness, etc., is in relation to the relative temperatures. Remember that. Now, this because this was uh, proposed, I would say, this theory was proposed during the Second World War. Some terms from military scenario came into this particular theory, and one of them is front. Okay, you'll see that the military moves ahead. Okay, moves ahead. Okay, so the front file of the people who are fighting, it's that is called as the front, and that is how this particular theory came up. Now, if you remember what happens as a part of atmospheric circulation at 60 degrees, what is happening is that you are having relatively warm air, which is coming from the tropics and which is going up here, and you're going to have cold air, which is coming from the poles and it is tucking itself there. Now, this, I would say, uh, friction, sorry, I was not able to change the color. This friction that happens between the cold air and the front air and the warm air is actually called as, is represented through what is called as the frontal theory as such. Okay, what has been done is that you have simply uh, you're looking at this whole scenario. These are also called as temperate cyclones. Okay, and they are relatively gentle as compared to what we see as tropical cyclones. Tropical cyclones have a lot of more intensity as compared to the temperate cyclones as such. And the frontal theory or frontogenesis is nothing but the sequence of how a temperate cyclone develops and how it dissipates as such is all we have to understand in this whole process as such. This is how it is actually moving, and in the whole process, you can observe this. Okay, now CP stands for
Con- uh,
CP stand
polar.
what?
Continental polar.
Yes,
Continental pole.
continent. Definitely, it stands for continental pole. MP stands for
Maritime tropical.
maritime
Maritime
Tropical.
polar.
maritime polar, and you have one more here, maritime polar. What is interesting is obviously you'll see that the characteristics of the air mass of this maritime polar are going to be not going to be the same. Okay, like this maritime, they will have their own characteristics as such. What is actually happening is you can see that you have what is this MT
Maritime
maritime
tropical.
tropical, and this is also maritime tropical. मी मगाशी जे म्हटलं की around 60 degrees, what is happening is air wind from this is coming in and you have okay थोडस exaggeration केलेलं आहे मी. So you'll see that the warmer air is moving like this, okay, and the polar air is gradually being sucked into this region. This area is going to be called as the front area. This is going to be called as the front area. Now, in this whole process, you have to remember one thing. Okay, this, okay, we have to, just a moment, let me clear the ink. Just give me some time. Yeah. Okay. Now this scenario. Okay. In this whole process, where do you see this scenario? You see here. What is happening? Okay. If you are locating at this, you can divide this into how many sections? Let me again change the color. जेवढे कलर चेंज करू आपण तेवढं ते इंटरेस्टिंग आणि ऑब्झर्व करायला सोपं जाईल. You have one section here. Okay. You have one section here, and you have a third section here. Okay, around A, around B, and between A and B. Let us see the same thing here. Okay, the same thing was here. Around A, around B, and then between B. Okay, we'll have to compare this and see continuously that what is happening around A, that this cold air is moving in. Okay, this cold air is moving in. Okay, now normally what should have happened? Normally the air should have come in like this and the air should have come like this. But then you'll see that the air is going like this and this air is going like this. Why does this happen? We have done this earlier. Why does this happen? Change in direction of wind.
Because cold air is
Yes.
a denser.
No, 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 no. Don't go that far. Okay. The change, the deflection in the direction of the winds is basically because of what? That National Geographic ball wala thing that we had seen. What is that force called? You throw a ball.
Coriolis force.
Yes,
Coriolis.
that's basically because the Coriolis force. Because of the Coriolis force, though you may have cold winds coming from here and warm winds coming from here, they actually change directions like this. And it is this change in direction which is going to bring about a lot of changes. What are these changes? Okay, this near the A you have cold part, near the B you have the warm part, and then in between you have this stretch. Let us observe the same thing in from the side. The same thing now. इथे आपण हे वर्ण पाहतोय from space. What we have done is here we have come to the ground, or very near to the ground, and we are trying to see what is happening. Okay, you will see that the cold air mass is moving. Okay, and as the cold air mass moves, it puts up its front along this line, and this is called as the cold front. This is called as the cold front. This is called as the warm front. This is called as the warm front. In between, you're going to have what is called as the warm sector. Okay, slowly now, let us see what is going to happen as such. Just a moment. We'll be using this particular diagram to see the stages. Let me change the color. Yeah, we'll be using this particular diagram to see the changes in what is called as the mid-latitude cyclone. It is called as the mid-latitude cyclone. As I said, it is not as intense and not as strong as a tropical cyclone, but you'll see that mid-latitude cyclone is going to take a lot of long time as compared to the tropical cyclone, which dissipates in a couple of days, at the most 3-4 days as such. This, as we said, this was proposed by Jerkins here. Now, how do you read this particular say? This is basically stages in the life cycle of a mid-latitude cyclone. We're going to start from A and we are going to finish at F. Okay, and you'll see here that this is A, this is B, this is C, this is D, this is E, and you'll see that this is going to be somewhere here, you're going to have F as such. So all the time while the cyclone is going to move from one end of North America or US, United States to the other, it is being tracked. What all again are we supposed to be looking into? Okay, you'll see that we spoke about these symbols here. Okay, a warm front. Just a moment, give me some time. I don't know why this file is. So these are the symbols, and we'll have to see what all this is about. We'll of course go into the details of them, but let us take it up one by one. Initially, what is the first stage? The first stage is the development of the front. What is happening here? Just see. What does this symbol include? This is a stationary front, right? Check करूयात आपण. What type of front was that? See, you have red up and you have blue down. Stationary front. What does that stationary mean? We'll try to understand it for ourselves. Okay, I will once again. Yeah, you'll see that what is happening here is that the warm, sorry, let me see, yeah, say the warm air from this side is trying to get into this area. It's getting into this particular area, and the cold from this side is actually trying to get into this area. Okay, so the line along which they are actually pushing each other, this is going to be called as a front. This line is going to be called as a front. It is this line which is being represented in this particular diagram in a three-dimensional way. Okay, see what is happening. Cold is coming from this side and warm is coming from this side. They get deflected because of the Coriolis force. This is the first stage of development of a so-called mid-latitude cyclone as such. Okay, slowly what is going to happen? Okay, what was straight here as a front, a straight line, and they're moving into each other. Gradually, you'll see that a wave develops. A wave develops. I think I posted the diagrams that I had drawn in on the blackboard in our group some days ago. These are the same diagrams as. Anyway, now what is going to happen is the second stage here. Okay, what was straight here slowly starts getting into a wave. Okay, and how does this wave look in three dimension? You'll see that this cold air is pushing itself here. Okay, so it's going to advance this side, and warm air is going to advance towards the colder areas. The cold air is going to come towards warmer areas, and warm air is going to go towards. So they are moving like this into each other. But in this process, what happens is warm air actually is lighter. Okay, warm air is actually going to be lighter. So there is going to be a third stage which is going to be developed, that is a cyclonic circulation tends to be established. Now, what is this cyclonic circulation? You'll see what has happened here. This is the cyclonic circulation. Okay, what was a straight, say a wave here gets divided into two parts, the A part and the B part. Let us say this is the A part, the warm front, and this is the B part, that is the cold front. Okay, let us slowly move ahead. Okay, this is the A part, this is the B part. Okay, now in three dimension, what has actually happened? Okay, you'll see that the cold air is actually pushing itself into the warm air, and because of this, the warm air is pushed up. Okay, it is pushed up. Okay, and here also the warm air is climbing up. The warm air is climbing up. Now there is a difference. In both the scenario, warm air is going up, but in both the scenario, while the cold air here is aggressive and it is pushing up the warm air, you'll see that you'll have a rainfall on this end, which is called as the cold front. You'll have rainfall along the cold front, but along the warm front, where the warm air is actually climbing up the cold air. Okay, the warm air is actually climbing up the cold air. What you can see here is that clouds are forming, but you don't have rain here. Okay, so within this particular area, this part will have rain, and this part will not have rain. So you see that you'll have rain in this part, while in this part, however, you will not have any rain. Okay, towards one side you're going to have rain, towards the other side you will not have rain as such. So this is the stage where actually the cyclonic circulation starts. Cyclonic circulation starts. Then we come to the fourth stage wherein the occlusion begins. Occlusion is a stage that you will find in the process of a mid-latitude cyclone as such. Now, what exactly do we mean by occlusion? Before that, let us erase all these things and come back to normal. Okay, this is where occlusion, this is how occlusion will look like. Okay, what is happening is this is slowly going up. This is being pushed up, and that you can see here what is happening. Okay, you'll see that this is moving ahead. As it is moving ahead, it is creating rain on this side. It is creating rain on this side. And as this is moving towards this side, okay, remember this end of the cold front. Okay, this is the advancing end of the cold front, and this is the retracting end of the cold front. Okay, you see it's similar to like this. You can see in the camera here that this is one end. That's a kaichi sarkha. It's like a scissor. Okay, this side is all cold. This side is warm. Okay, so the warm is being caught into these. Okay, the warm is being caught into these, and this scissor blades are going to close in. Okay, that is what is going to happen, and in that process, the warm here is going to be pushed up. The warm air is going to be pushed up. This will close, and that will be the end of the cyclone. But in between, all these things are happening. That they are moving. The warm air is moving in this way. The warm air is moving this way. Cold air is moving this particular way. And in this process, the cold air is actually going to scissor up. कात्री सारखं त्याच्या ह्याच्यामध्ये धरून you'll see that it is going to say lift the warm air as such. Okay, you'll see how it is being done here. Okay, you'll see that while here the distance was large, the distance that the warm area occupied was large. Slowly, the distance occupied by the warm area is going low. It's going low in the sense because of the fact the warm air is being pushed up. Warm air is being pushed up. This pushing up of warm air, okay, slow push up of warm air is called as beginning of the occlusion. Beginning of the occlusion. Occlusion. As it moves ahead, now see what is happening. Okay, you'll see that the cold front gets strongly established here, and this part is significantly picked up. Okay, occluded front developed. You'll see that this has climbed up, and this scissor that I was speaking about is nearly closed now. So when the scissor is going to be closed, okay, all the warm air is going to be pushed up, and that is what we have to understand as far as this particular diagram is concerned. A development of an occluded front. This is the development of an occluded front as such. Okay, and once this comes, okay, you have actually reached the last stage. Okay, you'll see that the whole warm thing gets lifted up. Okay, the upper layer is warm, the lower layer is cold. Okay, and once this happens, the cyclone dissipates. That's the end of the cyclone. Okay, so you'll see that when it reaches this stage, the cyclone has ended. That is the F part of it. Normally, there are 6 stages. Okay, the development of the front, formation of the wave, Cyclonic circulation established the third stage. Occlusion begins. Occluded front develops, and eventually the cyclone dissipates. These were the stages which were, I would say, suggested by Jerkins in his theory, and this is the theory of frontogenesis, or this is the life cycle of a mid-latitude cyclone as such. Okay, we'll just look into a few more. Yeah, what I've done is I've taken up these individuals, and again I have tried to put up a small explanation for this. Okay, front develops, the first stage. Okay, the diagram is the same. We'll check the explanation. A mid-latitude cyclone is born when two major air masses of different densities, that means temperatures, are moving roughly parallel to a front but in opposite directions. You'll see here Coriolis force is making them move into different directions. And that is why you'll see that a mid-latitude cyclone will not develop every time two fronts come together, because you require suitable conditions for that to develop. The frontal surface that separates these two contrasting air masses becomes a wave shaped and is usually several hundred kilometers long. Okay, though this looks like a block, okay, this is going to be a few hundreds of kilometers. Okay, this is going to be a few hundreds of kilometers in length as such. Now, as the wave evolves, the third stage, okay, as the wave evolves, warm front advances polewards. Okay, this is going polewards to form a warm front, while cold air moves equatorwards. This is equatorwards to form what is called as a cold front. Got it? Then what will happen? Okay, here occlusion will slowly start. What actually happens? Okay, once the cyclonic circulation develops, general convergence results due to forceful lifting. Okay, as I said, that because the cold front is going to close, the arms of the cold front are going to close. Okay, there is going to be a forceful lifting. Okay, what is trapped in this is warm. Because it is warm, what is going to happen when this starts closing? This is going to be pushed up. This pushing up is called as forceful lifting. This is called as forceful lifting, especially where warm air is overrunning colder air. Warm air is colder, overrunning cold air as such. Then this leads to the development of an occluded front. A cold front advances more rapidly than the warm front. As it moves, a cold front begins to overtake the warm front here. Okay, this part, the overtaking is taking place, and that is why warm front, okay, is put up, and that is why an occluded front is into a formation. Okay, once this develops, within 1 or 2 days, the entire warm sector is going to be lifted up. Okay, here, this is the lifted up. As I said, this is warm, lifted up, and the cold air surround. This is cold at the surface. The horizontal temperature difference that existed between the two contracting air masses is largely eliminated. And because this is eliminated, okay, why did this occur? Okay, this occurred basically because horizontal temperature difference. Now, because this horizontal temperature difference is eliminated, obviously the mid-latitude cyclone also dissipates. So it will start from here, 1, okay, move to here, then 3, then 4, 5, and 6. These are the 6 stages as such. Okay, when occlusion is occurring, okay, when occlusion is occurring, how do you actually look at these? Okay, how does it look sideways? Okay, you see that this profile, sorry, this profile is similar to here, and this profile is similar to here. Okay, here you'll see occlusion has completely happened. The warm air is top and the cold air is all the way near the surface. While the warm air is being picked up in this area, particularly, there will be rainfall. Okay, you're going to have rainfall in this particular area. As compared to that, here it is still open. The warm air is yet to be picked up. Okay, so where the cold air is advancing and it is forcing the warm air to rise, you will have rain. But where the warm air is climbing here, you will have different types of clouds. Okay, this is nimbostratus will give you some amount of cloud, but as it climbs up further, you will not have, you will have the altostratus cloud, you have the cirrus clouds, you have the cirrostratus. All these three will not give you rain. It is only the nimbostratus which will eventually give you a lot of rain as such. Okay, so that is what is happening in this area. Okay. We'll have to just once again correlate a few things. Okay, remember the maritime polar is pushing itself here, the continental polar is pushing itself here. Okay, this is E point, this is E point, this is D point, this is D point, this is C point, this is point C, this is B point, this is point B, and of course, this last here is A point. That is how you have to correlate. Let me tell you that this will have to be done individually. थोडंसं याच्यात लक्ष कॉन्सन्ट्रेट केल्याशिवाय हे होत नाही. Remember, this is to do with stability and instability conditions which we have done earlier also. Okay, just to go back to a few more things. See what is happening here. Started with this one here. Okay, warm front, conditional unstable air. Okay, initially it goes up at 2 kilometers, it will start condensing. This will lead to formation of cumulonimbus clouds. So it's in this section that you will have rainfall. याच्या आधी इथे rainfall नाहीये. त्याच्यानंतर you will not have rainfall here because the cloud pattern has changed. You have cumulonimbus in this part only. So you have heavy precipitation. And just check the length of this. This is 1600 kilometers, 1600 kilometers. Huge area. It is going to occupy a very huge area. Tropical cyclones will not occupy this much of area. It is only temperate cyclones which occupy this much amount of area as such. When you have a warm front, stable air, okay, this is what is going to happen. Then, this is another look of it. Okay, this is actually the cross section of AB here. What is happening? The cold air is advancing and pushing up. Okay, so occlusion is very near, but it has still not happened. You have some part of the warm air which is still touching the surface, so occlusion has not happened. Occlusion will happen when all the warm air is going to be picked up. Okay, so you see that these points here. Okay, this point here, this point here. Okay, this cold front is actually this point, and this warm front is actually this point. You have to remember that. And then occlusion has taken place. Occlusion front. You see that the last section of warm air is being pushed up. So all the warm air is pushed up from this point to this point. You have cold air, and above this you have warm air. You have warm air. Okay, because this has just started, it is called as partially occluded. Okay, it is the cross section has been taken at the point wherein it has been lifted. Okay, as far as this area is concerned, it has already been lifted. As far as this area is concerned, it is not being lifted. It is this point where it has been actually lifted, and here is where the occluded front is formed. Okay, this is the perfect formation of an occluded front. The warm air is completely lifted up. Okay, completely lifted up. What you have below is cold air. All of this is cold air. Okay, and while this is being pushed up, you're going to have light rain, sorry, in this region. Okay, when the cold front is very aggressive, okay, this is called as cold type of occluded front. Okay, when it is not aggressive, this is called as a warm type occluded front. Okay, and that is something that we have already done. That's all. So this was in short the this is also called as frontogenesis, by the way. This is also called as the frontal theory, by the way. These are also called as the stages as far as the development of mid-latitude cyclone is concerned. Okay, so the question, of course, you'll have an MCQ test, but when it used to be a theoretical uh, assessment, in that times, it used to be a bit different. Now, we're going to stop here today. Tomorrow, what we are going to do is we are going to discuss about our assignments now. माझ्याकडे सर्टिफिकेट्स अटेंड करून सर्टिफिकेट्स मिळालेली नाहीत असं कोण आहे आता?
सर मी
तुझं आधीच आलेलं आहे ना रे, सगळ्यात
नाही
आधी
आलं
तुझं
सर
आलं होतं.
माझं अजून नाही सर
You
ऋतुजा बोलते मी
चालते ना मग मी तेच सांगते ना
you may not have completed their procedures. त्यांनी ज्यांनी प्रोसिजर कंप्लीट केलेली आहे, they have given me their certificates आणि I have posted the document, the काय म्हणतो आपण zip file in our group also. You have to open that zip file and you have to extract your certificate out of it.
परत एकदा सेंड करता कसं
काय टाकली आपल्या ग्रुपवर, मी शोधा त्याच्यावर, चेक करा. आणि
सर
if you
त्या
have
झिप
completed
फाईल
all the
वरती पण
process,
नाव नाहीये.
open the zip file, dear. Open the zip file. You have all the certificates in the zip file. You have them in the zip file. I hope you understand what a zip file means. You have many certificates packed together in a zip file. They are compressed and they are packed in. You have to open that. We'll discuss about the assignments also, the remaining assignments, and we'll take up the next topic from tomorrow, the last topic, that is weather forecasting. की हे सगळं आपण जे शिकतो हे कशा करता शिकतो, that's basically because for we have to forecast the weather, and we'll take that up when we meet tomorrow. But before that, we'll have to set right all the assignments. I know थोडीशी गडबड झालेली आहे सगळीकडे, so I have to create a few assignments and space for you all to submit your assignments. I'll try to do it today, or we'll do it tomorrow itself. Don't worry about that. For now, I will stop the recording. If you have any queries, you can